Hello. Um, Welcome to chapter 3, exponential functions for grade 11. Today I'm gonna talk about, or now I'm gonna talk about common sense, a little bit of stuff that you put in your mind before you go to exam or test or something. And it's really important to realize these. For exponential wording problem, exponential, I don't know what's the spelling, okay, exponent wording problems. Okay, we're gonna have probably three kinds of problems. One of the problems that has interest rate, and one of the problems that is general feature of exponent, general features. Okay, and the last thing, it's what I like to call at minimum, at maximum, or something, or let's say transformation. Okay, and each of those has a specific function, a specific law or a specific equation. If you memorize it, then any exam you find, you can define this wording problem. Is it interest rate? Then you do this equation. It's a, we are going to explain all of these. A equal P 1 plus I over the power of n. Okay, so this is the first one. Don't worry about it, I will explain it. For the general features, you're gonna have y as output, a, b to the power x, and here, you know, very obvious, we're gonna have gx, or the transform function, equal the a, k, and d and c, all of that stuff. So it's gonna be a f k x minus d, and then you close it, and then you add up c. Okay, this is the transformation. So what is actually this? Let me take this and put it on a page alone. So I'm gonna page, new page after. Okay, so I'm gonna have a equals to, you recall, p 1 plus I to the power of n. Okay, probably this is talking about interest, retirement, business, money, banking, currency, blah blah blah. It's from this world, it's from economy world and financial world. The important thing you have to put in your mind is that simply a is the amount that you want to see at the end. Okay, so if I said, okay, I'm gonna be 16, and then I want to retire at 57, and then I will start with $5,000, and the interest rate is gonna be 5%, and then you plug all of the numbers, and then you do all the calculations, then you will get what? You will get a. So a is the desirable amount, or the thing that it's on the left. Okay, so you do all of this and you get this. Pretty straightforward. Okay, p is the initial amount you start with. So for example, if he gave you a problem with dollars, and then you started with 50,000, so it's gonna be like that. A equal to 50,000, or 50,000, and then 1 plus I, everything is the same. So this is the P, this is the initial amount. And then you're gonna have this bracket. Okay, I will explain this bracket later. Okay, and then you're gonna have N. N is the number of, sometimes the number of years. Okay, so it's gonna be the number of years or number of something according to the wording problem. So number of years maybe, or number of days, or number of centuries, or number of half-life, or number of anything, number of years, or any etc, anything. Now we're gonna have this one, this bracket. Okay, I here is the percent, I here is the percent. Now the tricky part is why I added 1 on here, and this is for educational purposes. This is to understand, like, it's okay if you memorized it, but you will never understand why. So now I'm explaining to you why you have 1 plus I. Okay, so I'm just gonna put a line on here. Suppose that at the first year, okay, the interest rate was 5%. All right, and you started with $100. Then you're gonna have 105, right? Okay, what if you have second year and you've got $200? How much percent you're gonna get? This is 5%. What's the total? You already calculated this. Okay, you already calculated $100, and now you're adding one more $100, right? So you add more, you add more, you add more. That's why we add 1 at every time, because this is a function, this is an equation. If you put 1 here, it will do all of this process automatically. Don't worry about it. Got it? Okay, so let's take an example of this so you can understand it. I'm gonna write the problem. I'm gonna just write the problem. I'm gonna pause, write the problem, and then start recording again, so we don't waste time. Okay, I'm back. Now we have talked about this law, and it's about interest rate and blah 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 stuff for the banking and retirement. Now I've wrote a problem. I've got it from the website. Now here, when you have this long many line problem, first you read it all. Okay, you read it very quickly. You read it all. You do not say, okay, this number means and that number means. You read it, all of it, then you start marking the numbers. So you have received 200,000. You, at the age of 16, decide to put some money away for retirement. You can find an investment that pays you 5% per year in interest. Assuming you will retire at age 67, how much must you put away in order to reach $1 million when you retire? Okay, now let's take it in chunks. Okay, you have received 200,000, so I'm gonna use the gray one. Okay, now let me just put the equation first so we do not get misleading. A equals P 1 plus I to the power n. Okay, you really can change these letters to anything you like, or your teacher like, in this context. Now here it says you have received 200,000, right? So this is the first number you face in this problem. You mark it like this. Is it something like A? No, this is not the future, because you have received in the past. Okay. um, it's not P, because here at the end says how much must you put away in order to reach 1 million. So this is actually what he's asking you about. He's actually asking you about P. So P is the question, I is not the percent, and it's not N. So you have received 200,000. It has nothing to do with the problem. He just put it here to trick you. Okay, this psycho man put it here to trick you. That's it. So actually we do not need this number, whether you receive 200 or not. Okay, why? Because here says you at age 16 decide to put some away for retirement. Okay, so you're gonna take from this a part of money, and you're gonna put it for a retirement. So you do not you do not need this number. You need a part of it. Okay, how much is it? Is P, and this is what we are going to solve. So you at age 16 decide to put some away for retirement. You can find an estimate that pays 5%. So now we're gonna have 5%. So I is 5%, or in other words it could be 0.05. Now I've got I per year in interest, assuming you will retire at age 67. Okay, now you're gonna retire at age 67. You can say that 67 is N, is the number of years, but you are already 16. So simply you're not gonna start when you are born, start saving for retirement, but after 16 years you decided to start putting some money away, and you assume that you're gonna retire at 67. So N actually is going to be 67 minus 16, which will give you 51. Okay, so N is 51. To reach $1 million, which is going to be A. So A is $1 million. Okay, now simply we just plug all of the numbers and we get P. So we want P, so we're gonna divide both of the sides with 1 plus I to the power n, and here the same thing, 1 plus I to the power n. So P actually is going to be A over 1 plus I over n, which is simply is 1 million over 1 plus 0.05 to the power 51. Okay, and when you do the math, I guess you're gonna have P is $83,051.71. So you should start with 83,000. So you take from this 83,000 and you start with it. This is how you do this problem. The next problems are going to be about the other stuff we talked about in here. It's going about this and this. Alright, I'll see you in the next video.